In example number 3, we need to evaluate the following integral. In this case, we're going to have the radical in the denominator. So we're trying to evaluate the integral of dx over x squared times the radical square root of x squared plus 4. Okay. This is the tangent substitution. Is 4 is 2 squared. So in this case, a squared equals 4, and therefore a will take 2, and we let x equals 2 tangent theta, and therefore the x will be 2 secant squared theta d theta. Okay, now let's deal with the denominator. This will be dx is the numerator. The denominator, we are looking at x squared okay, we are looking at x squared times the square root of x squared plus 4. After the substitution, it's going to look like this. X squared is 4 tangent squared, and inside we have 4 tangent squared plus 4. Square root of 4 is 2, which we're going to factor out, and we'll have 8 tangent squared of theta, and what's left after factoring the 4 is tangent squared plus 1, which is the secant squared. So we are looking at 8 times tangent squared of theta secant theta. So time to bring it all together into the integral. Let's call the integral I, just give it a name, and we started with dx over x squared times the square root of x squared plus 4, and with our new dressing we end up having the following. Dx is simply 2 secant squared d theta, and the denominator now is 8 times tangent squared of theta secant theta. So now we need to reduce it a little bit, and 2 over 8 is 1/4 outside the integral, and secant squared over secant is reduced to secant theta d theta. So that will be our new numerator. And the denominator will be tangent squared by itself. So how we proceed? If you go back to the days when you took trigonometry, and you learn how to do identities or verify identities or work with identities, one of the advice that it was given to you is sometimes the best thing to do is simplify all the trig function and express to the point where you express everything in terms of sine and cosine. This is a very good advice, and we'll go back and rewrite everything in terms of sine and cosine. So let's see. We have 1/4. The secant is 1 over cosine. And then we have 1 over the tangent squared. But 1 over the tangent squared is the cotangent squared. And the cotangent squared is cosine squared divided by sine squared. Okay. So the quantity in parentheses is 1 over tangent squared, and this quantity is the secant. And you can see that we end up having some reducing it. So we have 1/4. On top we have cosine d theta, which is great. And the bottom we have 1 over sine squared of theta. So here's the differential cosine theta d theta. This is a very desirable differential because it's the derivative, the cosine is the derivative of the sine, going back to what we learned in the section on trigonometric integration. So to expedite or to use this, we let u equal sine theta, and therefore du equal cosine theta d theta. Now our new integral is 1/4 integral of 1 over u squared du, or we can write it as the integral of u to the negative 2 du. The entire derivative of u to the negative 2 is u to the negative 1 divided by negative 1, so it will be negative u to the negative 1. So we have, let's write it here, we have negative 1/4 times u to the negative 1 plus c, and we'll write it as negative 1 over 4u plus c.